There's no slide. Oh yes, the slide is back. Okay, I will try to get quick through the slides. I will left some content away. Okay. Yeah, it looks good. You have the slide. I don't have the slide. So I'm going to talk about routers. I'm not going to talk about cloud infrastructure. I will not say the word Kubernetes. No, I won't say it. I'm talking about physical routers, could also be software routers we require to connect our cloud to the internet. This is the point of my talk. And of course, I will talk about the right side of the slide, about software-defined routers. As long as you do not require, let's say, more than 100 gigabit line rate throughput in your routers, you can go to software-defined routers using community hardware, bring several benefits for you and your budget. Yeah, and when you build the router, software-defined router the first time by yourself, maybe like me many years ago, you may follow this recipe. So you take some Linux distribution, which match your habits, some internet network configuration tooling to configure all your interfaces, IP addresses, etc., etc. And maybe you need some routing daemon for your IGP or EGP, whatever you need in your environment. And then you do, and when you have done it once, you do it again, and you build some automation, and you build it all the time again, and then you have, from time to time, you get the feeling, yeah, a generic Linux distribution is not that optimal to power your software-defined routers. You don't need some, let's say, no daemon for mounting your home drive on a router or other funny things you find on your desktop computer. So you get the idea you need some composition of all these requirements. So something like a kit to build a router. So all you need, obviously, is a router kit. And this is the idea behind the project. And not only having these basic features you will find in most Linux distributions already, but also bring some features for the senior network engineers like me. I'm working in this field for more than 15 years, and so you are happy if you have a feature like running config and startup config. So if you misconfigured your router, just let someone plug the power cord, power it on again, and it boots with the old config, and everything is fine again. And such things as serial console boot, of course, not the default in a generic Linux distribution. So what's all about it? On the one hand, of course, it's about an operating system, and the idea is to base it on Alpine Linux. And it's more like a blend. Maybe you know the term from the Debian universe. And it has some fundamental different approaches than VIOS. We have not enough time to get in detail, but we can talk later why I think VIOS is not a good approach to build a software-defined router. But it's also a place for related projects to improve the network ecosystem in the Linux field. If you're building software routers and software firewalls, you may recognize there are some fields of the available software. There could be improvements. I will show you later some examples. And all this is, of course, needs to be some maintaining, and that could be the RouterKit community. So the RouterKit OS. So I already said it's based on Alpine Linux, and the Alpine is a very lightweight distribution. You may know it from your containers, and it was never built for containers. It was originally developed for network devices. And it has a special deployment mode. You can run it in a so-called diskless mode, where it runs completely from RAM and from a temp bus. And there's a tool called LBU, which is local backup, which is to be used to save your configuration files into a configuration archive. So you're running configuration into a startup configuration and put it on a disk, on a thumb drive or USB thumb drive or whatever you have in your router or server. And next time the system boots, the init scripts will extract or discover and extract the startup configuration, the configuration archive, install all the packages which you have installed on your router previously, and restore the configuration, start all your daemons, and you're back in business. And so if you need a backup from your router, you just grab the configuration archive. And this is a neat feature. I don't know any other Linux distribution have such a feature set. And Alpine already has nowadays all the tools we need to build routers. When I began using Alpine, there was no Bird available. So I need to use containers on a router. That was very funny, but it works. And when building it as or shipping it as an operating system, you need some additional packages like installers and some scripts, meta dependencies, etc. And we need a mechanism to allow to backport focus packages. Let's say Bird brings an update, Alpine decided not to edit the update to the stable release, so we can cherry pick it from the unstable, from the edge branch, and make it available in the RouterKit. And the result is the RouterKit image. So it's almost just like a normal Alpine image, but it has this additional repository included and brings all the software packages which you need to set up your router. So it works even if you have no internet because your router is not set up yet. And yeah, at the beginning I said there are related projects. We already have some. One is student work by Göran. He is also here at the summit to implement a new connection tracking synchronization. If you ever used connection tracking tools, which are really old software, you set up multi-tenancy firewalls using network namespaces. You may already discover that's not scaling very good, and other projects. So whenever you think it's interesting or not, let's, oh, there was a slide shot. Let's talk together. We have a small website where we find all the ideas behind the project, and thanks for listening.